Start.
All right, welcome everyone. Very excited to have you all here today for this is a first for the data users meeting. We're going to focus this session on weather and climate information. The formal name of the session is Climate Information for Informed Decision Making. So my name is Mark Jekanowski. I'm chairman of the World Agricultural Outlook Board. And as I noted in the session just previous to this, we're known for putting out the WSDE. And if you know anything about the WSDE, you know that we rely heavily on meteorological data. We were very fortunate to have an excellent team of meteorologists on staff who we rely on heavily to understand weather conditions both in the US and globally. We truly do cover the entire globe. So we wanted to arrange this session to kind of highlight some of those efforts and also, as you know, highlight some of the links we have with other agencies, agencies across the government, including NOAA and the Drought Mitigation Center, folks that we work closely with in those activities, including the Drought Monitor. So with that, very happy to have for you today four presenters from three different agencies, including the World Board. They're each going to give a quick presentation, and then we can open it up to some Q&A. And I encourage everyone to put their questions into the Q&A box, and we will work through those. And happy to engage with any questions you might have. So we're going to kick things off today with Mark Brusberg. Mark is the chief meteorologist for the Office of Chief Economist in the World Agricultural Outlook Board. So he leads the weather team within the World Board, and he'll be followed by presentations by Dr. Mark Zvoboda of the Drought Mitigation Center, along with Brian Fuchs, who also works with him there. And then Dr. Dave DeWitt, who is the director of the Climate Prediction Center of NOAA's National Weather Service. So with that, Mark, I'm going to turn it over to you, and then you can hand it off to the next speakers. And I encourage the participants to get your questions ready. It will be ready to engage you right after these presentations.
All right. Thank you, Mark, for that kind introduction. What I'd like to talk to you about today is not just the weather information going into the creation of the WSDE, but I wanted to show you how we've expanded our capabilities over the last 30 to 40 years or so. We've got a lot of new data products that we use, even though we still have some core information, but along the way we've picked up some new products and some new techniques for using that data to come up with our yield assessments. Next, please. Okay, and I won't rehash the history of the Great Grain Robbery, but as you all know, one of the reasons for the existence of the World Board and USDA's economic intelligence infrastructure is, that we need to keep an eye on what's going on worldwide. Not only is it a global economy, but we have opportunities to target resources for American farmers, and we also need to keep an eye on people who are going to be our competitors. Next, please, Marissa. Now, in that structure, you see that there's, in that little blue bar, the meteorology staff. I'm the chief meteorologist, and there's a group of 5 of us who provide weather intelligence in support of the WSDE and USDA's economic, intelligence activities. Our unit is referred to the Joint Agricultural Weather Center. Next, please. And it's not because we're separate from USDA, but this is a partnership between USDA and NOAA. USDA and NOAA have an MOU, a Memorandum of Understanding, and in that memorandum, there is a discussion on how we partner with the National Weather Service. We receive products and data from them. Next, please, Marissa. And these products form the basis for what we're able to accomplish in our assessment work. Now, this is a random sampling of weather data that we get. Typically, every day, we receive weather data, rainfall temperature data from anywhere between 7,000 and 8,000 stations all over the world. Next, please. And as you can imagine, this is a very powerful tool for us. Now, what I've done is I put together some slides showing an example of some of the techniques that we're able to use just using that WMO data. This is an example for Paraná. This time of year, we're monitoring their second corn crop. And as we can see, we can compare this year to other years just looking at the rainfall data, just to get a quick glance at where we are. Next, please, Marissa. Thank you. And then this is a chart. We can go back 30 years and we can make our own products. This is a calculation of the days between rainfall, which is very effective in telling us when they've had excessive spells of dryness. Next, please. And then we can also take it a step further and use that data in simple regression modeling. This is an example for second crop corn. And just by using elements of rainfall, temperature, days between rainfall, we can get a good idea of what the yields are going to be. And next, please. Unfortunately, the WMO data is not great everywhere, if you will. And I want to show you the example of Mexico. On the left are the data that we get from the World Meteorological Organization. And there's about 70 permanent sites. On the right is rain gauge data that we get from the Weather Service in Mexico. And it looks like overkill when you're looking at 900 versus 70. But Marissa, if you could show the next slide, we see that the analyses are not adequate. And a lot of this is due to the terrain. And on the left-hand side, just looking at the WMO data for this particular example, it looks like they just got rain everywhere. Well, that's a dangerous assumption to make because in April, they're planting corn. And if all we had was the WMO data, we would have assumed that they were planting corn across their corn belt, which they were not. And you can see on the right-hand side, this is what it looks like just using the data from the Mexican government. And could you show the next slide, please? We have other tools as well. On the left-hand side is a CMORPH, basically satellite, a composite of all the satellite-derived precipitation. You can see this matches up with the weekly rainfall from the rain gauge. And again, this is another product that we receive from our partners at Climate Prediction Center. So you can see that it's, having the WMO, which is the backbone of our analyses, works well in a lot of places, but sometimes we need more. And fortunately, we've been able to take advantage of the newer technologies. Could you go next, please? We have other satellite products as well. This is a vegetative health index product, and this is going back to southern Brazil in the red. You can see that the vegetation last year was much worse than it was 2017, which was a better year. So we can visually show not just rainfall, but also the impacts that it's having on the actual vegetation. And this is a relatively new product that we've been bringing along through our partnership with NOAA. Next, please, Marissa. Now, not only is the data improved, we have access to more data, but our ways of looking at the data have modified over the years as well. Now, this is the next few charts are going to be courtesy of my colleague, Eric, who is our, Northern Africa analyst. And looking at drought classifications, which are now very common, and you'll hear about that when Dr. Svoboda speaks, but we're able to take these weather elements and show them how they fit historically. And this, again, this isn't just one product that we're using to say that there's drought, but it directs our attention to the areas we need to focus on. Next, please. And then we have, I showed you the regression model. We're taking it a step farther now. And again, you know, my colleagues Harlan and Eric sort of blazed the trail for this, but now we're able, not just with the weather data, but also the satellite information and derived products, we're able to look more closely at each element for each country. So in this example, you can see that, you know, Morocco, we're looking at rainfall. Wheat, you know, the wheat crop tilling through flowering. What is the contribution of the yield just by that element? Next, please, Marissa. And then we're looking at the VHI. And one of the things we're finding out is we can look at rainfall and temperature, you know, values, derived products like soil moisture for a certain time. That seems to have a better, you know, better describes what's actually going on with the yields. But then we can use the satellite VHI as well. And here we're finding out that VHI for the wheat at heading is more significant than the VHI at other stages of development. And we can parse that out and we can test it. And a lot of that is not just the newer products, but also the newer software. You know, we Excel, obviously, but, you know, the database packages that we didn't have 30 years ago. So we've been trying to do our best to take advantage of new technology as it comes to us. Next, please, Marissa. And then, and again, this is an example for South Africa from, you know, one of my areas. Now, given that we've been able to break down what the temperature impacts are most, you know, which ones are most relevant, which time of VHI is most relevant, we can paint this picture of, you know, here's where the crop is, here's what it's most vulnerable to or can be most supported by, and then we can do a better job within the year of describing exactly how we see the crop faring. And again, that's much better than it was 30 years ago, when we basically had to wait until the end of the year. Okay, and next, please. And then again, this is sort of a wrap up of what we saw in South Africa. And, you know, looking at these techniques gives us a range of yields, you know, see what the possibilities are, but it also helps us to focus, you know, on our range. I mean, you wouldn't say, well, because of these conditions, you know, the yield's going to be 3 tons per hectare. Okay, but we're able to narrow it, and we're able to narrow it with the help of the weather data that we've been accumulating these past 30 years, improved technology, improved techniques, and then the new products that we get, you know, through our partnership with the National Weather Service. So when you see the front page of the WASDE and you see statements saying that there was a drought here or the weather improved this month, this is the basis for those statements. Okay, we're using good quality data. We have quality products that we're incorporating, and now we have decades of track record that is helping us to, you know, get things, you know, a little bit more correct a little bit earlier. So I guess that's how I could summarize it. So next one, please. Basically, I'm done. I want to thank everybody for this opportunity to speak. If you want to know more about us, our link is at the bottom with all of our products, and then you can contact me directly if you have any questions. So once again, thank you very much. Thank you for your assistance, Marissa, and I will turn it over to another Mark, Dr. Mark Svoboda, Director of the National Drought Mitigation Center.
Thank you, Mark. Yeah, first off, just want to express our thanks for having us on board today to present to you all and get some feedback perhaps here at the end of the session. Brian and myself are going to give a quick overview of the Drought Center and some of the more USDA-centric applications. Obviously the Drought Monitor, but maybe a couple other tools you don't know so much about. And then we'll wrap it up and pass it on. So next slide, please, Marissa. Just quickly about the Drought Center. We've been around since 1995, and USDA's been a partner and supporter since day one. Most recently, the last 20 plus years through these cooperative agreements with the Office of Chief Economist. There is why we're working with folks like Mark and his staff, and also with Seth and the OCE staff on econometrics types of work. Our whole goal at the Drought Center is to translate the science of drought to the public, to the media, and to our partners and our collaborators. And with the goal of creating usable information. And you're going to see that, I hope, with some of the tools that Brian will talk to you about here in a little bit. Our staff is made up of 50% physical scientists and 50% social scientists. So we do quite a bit of work with the stakeholders on the ground, getting co-design all the way through a process to what you see as a final tool. Next slide, please. Sorry, one more. Yeah. So just to give you a little bit of an idea, a lot of the lessons we've learned, a lot of the context we're talking about is drawn from our experience working with groups all over the globe. Yes, we're the National Drought Center, but we're working, have worked with over 80 countries over the last 20 years. Those countries in dark blue most recently, you can see here. And with groups like the United Nations, developmental banks, and other partners globally, not just here in the United States. So with that, I'm going to turn it over to Brian to get a little bit more into the Drought Monitor and a few tools, and then I'll come back and talk a little bit at the end about some policy applications using the Drought Monitor to finish up our presentation. It's all yours, Brian.
All right, thanks, Mark. So the Drought Monitor, again, this was the science coming before policy. I think that's the key point, especially with the relationship to USDA programs now, that the connection between the Drought Monitor and these relief programs have been made. And, you know, we've been around since 1999, and this is a three-way partnership again as well between the National Drought Mitigation Center, NOAA, and USDA. We all come together to put this product together. We have the web page that's out there, and there's a lot more than just the map. I think a lot of people get focused on the weekly map that comes out and what it's being shown, but there's a lot of information that can be dug into off the web page, and I invite you to go and visit the full web page to just see everything that is offered. Again, this is the go-to source for drought information in the country, and what I call is the gold standard for drought monitoring around the world. We have many countries that are interested in trying to mimic the process that we have here in the United States. And it is the go-to source for information. In times of fairly significant drought, we'll get anywhere from 12 to 15 million web hits, and a lot of media attention get towards the process and the product. And in years like 2012, where we had significant drought over the grain belt, some of those numbers were well approaching that 20 million number for the calendar year. So the Drought Monitor is important, and we put a lot of time, effort, and energy into it. Next slide, please. So in making the Drought Monitor, the backbone of it is this percentile ranking methodology. The idea is we can take any indicator that we have available to us, regardless of the period of record, and we can rank that current information compared to historical information, and each one of those percentiles will fall into the D0 through D4 categories. So for example, to have moderate drought on the map, that's saying that the majority of our indicators are falling in the 11th to 20th percentile. And then when we start looking at areas like D2, D3, D4, D4 drought being the first to second percentile, that's saying that drought conditions like this should only be happening 1 or 2 times in a 100-year period. It does allow us to put current information into a historical perspective. Next slide, please. So what we have done with our partners at OCE within USDA is we've taken some of this information associated with the Drought Monitor, and especially with some of the new relief programs that are in Farm Bill, we tried to make some tools that are available for not only the USDA field office personnel, but for anyone who's interested. Again, you can see that based on the Farm Bill criteria, you can see if an individual county is eligible for the relief program, which counties are eligible. And ever since we expanded the drought monitor to the U.S. Virgin Islands and U.S. Pacific affiliated islands, we're able to provide information if those island states are available for any relief program as well. And so next slide, please. I'm just going to show an example of how we're doing this. So there is this online tool, and the previous slide had the URL, and you can put in your criteria. So within the LFP program, there are some criteria that can be met to reach certain payout levels. So on the left-hand side, I'm showing how the specific criteria that you're interested in can be chosen. You can choose your location. So you can either choose for the entire US, or you can go by state. And by state, you would get your information in counties. And then for the LFP program, it's attached to a unique grazing period. So every location has a unique grazing period that is established by USDA. So you can put that criteria in. And I just used this April 1st to end of October grazing period. And off on the right-hand side, you can see the results then of counties that are eligible based off these criteria to meet payment schedules associated with the LFP program. And again, this is just a snapshot of the spreadsheet that's available from this output, but it is an Excel spreadsheet. You can sort those. You can see that the FIPS code is given, and it does provide a lot of information for especially those USDA partners that are working at a service center or a local FSA office, that if a producer comes in and wants to know, hey, am I eligible? Not only can they pull up this information themselves and show that, but they can share these URLs with producers as well to help them get a better idea of when they would or not be eligible for programs such as the LFP. Next slide, please. Another product that we've been working closely with Mark Brusberg's group and using the Ag Census data is this agriculture, commodities, and drought. And so basically what this is showing is this, again, this is an interface that users can use to go and find this information associated with these commodities. But this information is available that people can go in and see, again, what are the alfalfa acres that are under drought right now, or the cattle inventory that's associated with drought. So if we go to the next slide, I just have some screen captures of some of the various products that are coming out of here, and there's a whole suite of information. So on the right-hand side of this panel, you can see that there's corn areas in drought, or cotton areas in drought, soy and sorghum, wheat, and other grains are available here. And on the left-hand side, you can see that there's cattle areas, or sheep and lamb areas, milk cow areas. And then on the bottom left, you can see that this information is provided over time. So you can get an entire time series to see how this has been behaving through the history of the drought monitor. What's nice about these reports is they do come out every week, and you can easily see the amount of a grain area that's in drought, or one of the other commodity areas that are in drought, and can relay that information quite readily, both in a visual using these maps, but also with the statistics. And the next slide. And I'll pass it back to Mark to finish us off here.
Thanks, Brian. So yeah, I thought we'd sort of wrap it up, and Brian kind of hinted at the variety of applications right now being used. We started off obviously without any ties to the drought monitor, which was probably a good thing. You know, it wasn't forced down on us. We were able to get the science in good shape before it became a trigger. You know, for example, here on the right, you know, fast track designations from the U.S. Department of Agriculture Secretarial Office is a major improvement in efficiency of responding to the disaster of drought. If you may recall, just not that long ago, back in the 90s, it might take months or even into the next year before a producer was seeing any sort of benefit or response to a drought from the previous year. So there was a real lag involved. And now with the drought monitor as this trigger, which involves many inputs covering the entire hydrologic system. I think that's really increased efficiency such that these maps that you see here can be updated every week for those drought declaration designations by the Secretary of Ag. So that's the big one, the Farm Bill. That's what really probably put it on the map as a trigger back in 2008 and was renewed and modified a little bit in 14 and 18. And that is done independently through the Farm Service Agency. So there's an avoidance of any bias. There's a detachment between the drought monitor authors and what they're using the science to make the map, and then how FSA and other programs within USDA use it as a trigger. So I thought I'd also mention, you know, outside of USDA, just FYI, we're seeing this used for tax deferral for livestock within the Internal Revenue Service, for non-federal hydropower project regulation through FERC in the Department of Energy. Water quality issues are becoming bigger and bigger, as is health. So that involves EPA and Centers for Disease Control and Prevention. They use it in their briefings for vectors of disease and or other issues, and some of that can be waterborne as well. And also more recently, the Bureau of Land Management for livestock grazing. So it has a really strong agricultural flavor to it, but we are seeing a couple other usages of the drought monitor. This has resulted in billions of dollars of support to their constituents, a lot of that through the Farm Bill, a lot of that through Farm Service Agency in particular. And we keep trying to find ways to enhance and improve that through our coordination with Mark Bresberg's shop and Seth there with the Office of Chief Economist. And then the last thing I'll mention as far as where you see this, obviously many states also use it as a trigger. So there is a coordination there between local level to state to federal. And we're working with the climate hubs a lot to look at other ways of validating this, enhancing this product, developing other tools like what Brian touched on as a way of moving the drought monitor along and not becoming static. And that's the beauty of that product. It's not a fixed formula. It's able to integrate in new products as they become available, and makes the drought monitor, hopefully in the future, more accurate and more usable. All right, next slide, please, Marissa. I think that's it for us. So again, we can circle back to other specific questions in the chat or through the Q&A at the end. But now we're going to turn it over to Dave DeWitt with the Climate Prediction Center.
Hey, Dave, do we have your audio?
Yeah. Sorry, folks. Can you hear me?
Yes.
Sorry, I think I had mentioned I have a plumbing emergency. I have to deal with something for 30 seconds and then I'll be right back.
While we're waiting, in the meantime, we had one question in the Q&A, which Brian answered online, but if I'm not sure if everyone in the Q&A can see the questions and answers. So just in case, if not, the question was regarding Drought Monitor. Can you talk about how the monitor is adjusted week to week? Is it automated or adjusted by someone? And is it the same person that updates throughout the year? Brian, do you want to just talk a little bit about that?
Yeah, Mark.
Yeah.
So that's a good question, and I didn't dig into that much at all. We have 10 authors between NOAA, NDMC, and USDA that we rotate the responsibility of making the map. Typically, we do 2 weeks at a time and then pass it on to the next person. It's a manual process. We're using GIS and GIS data to bring several dozen data sets right into a GIS mapping project, and we adjust those lines manually, again, using that convergence of evidence approach of several dozen drought indicators and indices with that ranking percentiles methodology background.
All right, thanks, Brian.
This is Dave. Sorry about that. I'm ready to go. Sincere apologies.
Go ahead.
Yeah. So I'll give you the backstory on that. I had a pipe crack in a hidden wall, and of course, I'm very fortunate to have the plumber come out today, but he's just finishing as I'm starting. So again, my apologies on that. So I do want to thank people for the opportunity to speak. My name is Dave DeWitt. I'm the director of the Climate Prediction Center. Today, I'm going to talk about a product that we produce that you may not be familiar with. That's the CPC Week 2 Hazards Outlook. This outlook warns of extreme events in the day 8 to 14 timeframe. Next slide. So in terms of what I'm going to cover, I'm going to briefly describe the general concept of subseasonal to seasonal prediction. Next, I'll give an overview of this CPC Hazards Outlook and an associated tool that can be used by stakeholders to determine the probability of different extreme events occurring. I'm then going to cover some examples of extreme event predictions from 2019 using this hazard outlook, and how that event or those events were messaged by the National Weather Service field offices and partners such as the NOAA Regional Climate Service Directors, Regional Climate Centers, and the USDA Climate Hubs. And then I'll close with a brief summary. Next slide. Yeah, so this diagram, which has time scale going on the x-axis from left to right, and then uncertainty on the y-axis. You know, where the cone is wider, there's more uncertainty. So as you move down towards the shorter time scale, obviously the forecasts are more certain. There's higher predictability. So, you know, what's on here represents forecasts produced by CPC on different time scales. And whether or not a particular stakeholder uses a specific product depends on two factors: the skill profile of the product and the risk tolerance of the stakeholder for that decision. The hazards, which are represented on the rightmost part, are our shorter timescale products, and they represent forecasts of opportunity when we anticipate increased predictability for high impact or extreme events. So for instance, heavy rain, or much below normal temperature, or much above normal temperature. Next slide. So as previously mentioned, the hazard outlook is for the day 8 to 14 period, and it shows the probability of extreme events such as much above or below normal temperature or much above normal precipitation. Also, there's a wind criteria as well. The map is issued daily, Monday to Friday. The format of the outlooks is probabilistic, and the maps are drawn in what we in the Weather Service call a human over the loop process, where the forecaster integrates information from several different tools and then produces the outlook that we share online. Next slide. So one of the main tools that the forecasters use to generate the hazard outlook is the probability of extremes tool, which is shown here. This tool allows the user to see the likelihood of extreme events at their locations for different days in the day 8 to 14 period. The tool is based on the Weather Service Ensemble Prediction System, the global model known as the Global Ensemble Forecast System, or GEFS, which was actually just recently upgraded last November. This tool is publicly available on our website, so anyone can use it. So I encourage you to check it out. On the right are the different criteria that you can set to get probabilities of what might happen given their respective forecasts. Next slide. So now I'm going to show some examples of the hazard outlook, and the hazard outlook for this particular date, which was issued on 21st January 2019 in the leftmost panel. The format of the outlook, as you can see, is given as 3 classes, which are slight, moderate, and high probabilities of being in the upper or lower 15% of historical events. And so here, clearly, we were calling for much below normal temperatures, or you could call it an extreme cold air outbreak in the central United States. The middle and the right panel show the actual temperature record from that period. and both of these sites experienced near record cold. The blue shading actually indicates the historical range, and the bars that you're seeing towards the bottom of that range in both of these cases are showing that we actually almost did set records in those cases. So the forecasts were quite good and they were quite useful. So in terms of how that, next slide, in terms of how that information was disseminated, this shows various National Weather Service Outlook facilities, either the regional center in Kansas City or the WFOs. And the intensity there, you know, red is more intense, is the number of outreach events that each of these offices sponsored associated with this cold air outbreak. So quite a lot of intensity there in the north central United States regarding this cold air outbreak. And that sets up our partners downstream to use that information for their respective decisions. So in terms of what the local messaging looks like from some of these WForecast offices, in particular with respect to this specific event, next slide. Yeah, so these are messaging of that particular event from several different Weather Service offices. The offices shown here include Chicago, Bismarck, Des Moines, and Sioux Falls. Other service partners such as the NOAA Regional Climate Service Director in that region, Doug Cluck, and the USDA Climate Hubs, Dennis Toddy, also messaged this event. So you see each of the offices has their own messaging style, but they all came or put forward the same message that there would be really extreme cold over this period. I don't have the verification data in this presentation, but it verified very well. Next slide. So this is another example. This is for flooding. And the left panel shows what the hazard outlook looked like at that time. Again, smaller region here, and up to only a moderate probability of extreme rainfall, but still a significant chance over a fairly large region that we might have this extreme event. And the middle panel shows the background soil moisture state at that time. So you see that and well up above 99% soil moisture over a large region. So very saturated soils, as it had been raining quite a lot in spring. And even earlier in that year. And then the right panel shows the river levels, which were at or above flood level at that time. So you had a very strong possibility of heavy rain occurring on ground that was already saturated. So a very large chance for significant increases in the flooding that was unfortunately already occurring. Next slide. So this event was messaged by our partners, seen in the left-hand panel. This particular messaging put forward again by our colleagues in the central region, Doug Cluck, who's the Regional Climate Services Director for NOAA, Dennis Toddy, who's the USDA Midwest Climate Hub Director, and then Kevin Lowe from the National Weather Service River Forecast Center there in Kansas City as well. And of course, the middle panel, this was especially devastating as we had already had a lot of delays in planting. This particular map is actually from our USDA partners at the Office of the Chief Economist. There had already been a lot of delays in planting due to the spring flooding. And so this again was a compound event. And then on the right, just listing the partners who we were messaging this event with again. We, of course, have a national footprint at the Climate Prediction Center and provide the national forecast, but a lot of the what we would call decision support services, what you might call messaging, is messaging to partners is done through these local outlets such as the regional climate centers or the USDA climate hubs or the Regional Climate Services Director. So the next slide just shows a quasi-verification that in fact we did get heavy rain. Obviously, as with any probabilistic forecast that has an 8 or 10-day lead, certainly not perfect. And there are some regions that did not get heavy rain, but there are many that were. So that's the sort of flavor you can expect with probabilistic forecasts on this time scale. You know, the region for which you will warn, just like the region for which you would warn for a tornado or a snowstorm, will be bigger than what actually occurs, and there will be some inconsistencies. But the attempt, again, is to inform the stakeholders of the potential for an extreme event so that they can prepare as best they can. And obviously, as you get closer and closer to the date, the accuracy of the skill will get better and better, as I showed on that slide with the cone of uncertainty. Final slide. So in summary, the CPC Hazard Outlook highlights the areas of potential extreme or high impact weather events. This is for temperature, precipitation, and winds. It's for the day 8 to 14 time scale. There's an interactive web tool available online that people can use to see probability of extreme events for their area. Do want to thank Dennis Toddy, Brad Rippey, Kevin Lowe, Andy Foster, and Ray Wolf, who provided figures for this presentation. We're always interested to get feedback on our products and how they can evolve to better meet your future decision-making needs. So thanks again for the opportunity to speak. Sorry about the plumbing problem.
All right, thanks, David. That was great. And thank you to all of the panelists. Great presentations, good background information. So now let's turn it over to the participants. If anyone has questions. And as we get that started, I see there were a couple questions in the Q&A that Brian had already addressed with written answers. Brian, would you want to say a few words about either of those for the benefit of the rest of the group?
Yeah, there was a couple of questions talking about how soil moisture is being accounted for in the drought monitor process. Mm-hmm. And yeah, that's a pretty complex question, and could probably spend a lot of time going over that. But I think Mark had provided some answers, and myself in the Q&A box, that we are looking at several different soil moisture models for the most part. Each one of them has different attributes as to why they may or may not show certain conditions better than another model. And so with that in mind, and with the drought monitor process, we try to incorporate as many of those soil moisture models at the various depths that they provide estimations of moisture at within the process. So we don't just look at one, but we look at as many as we can. And we do look at the various depths that they provide. And each one of them is built a little bit differently. So I saw there was another question asking about the soil attributes and how they were accounted for. And each one of those modeling systems does this in a different way. And there's probably others who can speak a lot better to that than I do, but they are trying to account for the different soil characteristics. I know the Surgo data is being utilized in some of these models as well to try and get a better idea of how certain soils are holding the moisture that they have available to them. I think that covered, and we already talked about the drought monitor question. So I think within the Q&A box, I did also provide a link to an online tutorial about the U.S. Drought Monitor that really gets into depth discussions of how we do that work each week. If people want to go and visit that link, it is available in that Q&A box.
All right. Good, thank you. Let's see, a couple other questions came in. Let's see, Mark Brusberg. Maybe you can say a few words on this question from Bill McCary. Question is, could you provide a weekly crop conditions for foreign countries based on SAT, precept, and index?
I've seen that attempted in terms of not in terms of crop condition, but in terms of using satellite products to try to determine yield. I think that personally, I think it's very difficult. I mean, we know even in the United States, crop condition doesn't necessarily, correlate directly with yields. So I think, having said that, I mean, we look at vegetative health to try to get an idea of what the vigor of the crops are at a moment in time. But again, we have to use a lot more tools that we have at hand to do that. I would recommend that, several countries like Argentina, for example, they do publish crop condition. So if you wanted to take a look and, maybe if you have a product that you'd like to experiment with, try to find a foreign location that does report that and, just see what happens.
All right. Thanks, Mark. I'm looking in the chat window too. And again, I'm not certain what questions everyone, all of the participants can and cannot see. So,
yeah, Mark, I think some of those, the responses were not going back to all attendees. You may want to take a look at those that went back just to the panelists.
All right. Let's see, and maybe, let's see, since we don't have any other questions pending that I can see, maybe if panelists, if we can just go through a few of these in the chat, and if there's anything there that you want to expand upon. Question here from Bill Lapp. Weekly percent of each crop in drought, great charts, but the bar chart for wheat does not have Oklahoma, and this would be very useful. Is there a person link where this feedback can be provided? Mark, I think that answer just went back to the panelists. You want to just speak a little bit on that?
Yeah, Mark, I did answer that. I scrolled down. I reached out to our GIS expert and asked him why Oklahoma wasn't in there. I did not know it was not in there. I mean, I never paid that much attention to each and every individual state. And apparently when he was compiling the statistics from NASS, there were some counties that, had blocked information. And he said that it was to a degree where he wasn't, able to get a good percent of the state total in there. So it's basically a data availability, and you see that occasionally in other crops and commodities where the states they don't completely report what they have, and I mean we have to access it the same as the public. So some of the data was not there. I think that in the future we may put maybe a not available there, so that people, will recognize that we are using all of the data that we have. So I want to thank Bill for bringing that to our attention.
All right, very good. I noticed another question here in the chat. This is kind of a, not sure who this would go to, maybe Dave, maybe one of the Marks. Has there been any significant improvement in the 6 to 10 day forecasts over time? Any academic work on this?
Yeah, hi, this is Dave. So I think I'd have to ask you what you mean by significant. So I would say there certainly has been an improvement in forecast skill in that second week. So either day 6 to 10 or 8 to 14, and we can measure that. And that's largely on that time scale due to improvements in the global models and the ensemble system. And so there are graphs on this that we have that show that. Unfortunately, on the longer time scale, on the monthly and seasonal, there hasn't been a similar improvement to date. And in fact, NOAA, the Weather Service, and NOAA are trying to launch something called the Precipitation Prediction Grand Challenge that really focuses on that all time scales, but really focuses on that beyond week 2 out to the first season time scale. That's a really challenging problem. And, I think it's fair to say that on that time scale, there has not been a lot of improvement for a long time. Part of that is model resolution. Part of that is challenges with the physics. And I think we have an alignment these days with an administration who's very proactive about climate, and Congress that also is similarly interested that we may get investment to try to accelerate improvement on that. So
good, thank you, David. And I'll just note we have only about 5 minutes left, and we do have a hard stop since there's another session right after this. But I see there's a question just came in through the Q&A. Mark B, this one might be for you if you can see it. Essentially, it says, how long does it take for the vegetative health index data to be finalized? And
That's a good question. That is being refined. I don't want to say continuously, but I believe that the process will go back a couple of months where they will, just take a look at the satellite imagery, make adjustments based on all of the information as it comes in. Obviously, what we get is a preliminary look. I don't know that it changes a great deal, but you do have to be careful because they, and this is NSDIS that updates the data, once they get more information and they do update it. So I want to say it's between 1 and 2 months where they will go back and try to make any corrections.
all right, good. Thanks, Mark. Let's see, one other question that just came in through the chat. Let's see, I'm going to read it to you. This one probably also is for you, Mark. We'll see. It says, thanks. A lot of the presentation showing how USDA is looking at the weather products and arriving at the yields. Are there any published papers on some of the approaches presented used by USDA? For example, Morocco wheat yield based on VHI, precip temperature data based on yield model, etc. Any guidance will be helpful.
Boy, thank you for that. That's a good question. I guess we've presented these findings at conferences. We have not done peer review on most of these because we just frankly don't have the staff or the time to do that. We're doing things operationally, and so yes, we would like to be able to present these and get other people's feedback, but we just don't have the capacity to do that.
Right. And I would just add that on the other hand, they are being continuously tested in real time. So you and your team are making adjustments and improvements as needed and as you learn. Well, okay, hold on. I think we have time for this one last question from Chris Eggerman. Is there a week 1 to 7 day US forecast available in a similar format to the 6 to 10 day and 8 to 14 day forecasts?
So just to make sure I understand the question, so are you asking if there's a tercile probability forecast for the week 1? The answer at present is no. There is not one that is produced, to the best of my knowledge.
All right. Well, and I think with that, we're probably going to have to leave it there. We're within a minute of having to shut things down. So I'd like to thank all the panelists for a great job in providing a lot of good information, and all the participants as well for joining in. Hope you learned something, and we'll hope to see you at one of the next breakout sessions, either directly following this one or tomorrow. And with that, I will turn it back to Marissa.